Hello everyone, we are here to present our approach on the friends recommendation systems that our team built. This is me, Saurabh Singh. We'll straight away dive into the high level idea of our project. We started with downloading the data from the internet using the Facebook Graph Exploration API. We then pre-processed the data into the format that one of the three algorithms that we designed used. Throughout this presentation, we're going to talk about each of those three different blocks. We'll start off with the data pre-processing stage. As you can see on your screen, the number of different unique users we had originally was 60,000 unique users. We went ahead and removed those who just had one mutual friend. And after the pre-processing stage, the number of unique users that we were left with were 55,000. On your screen is some of the statistics to display the type of data we were dealing with. The number of mutual friends, the average number of mutual friends we had in a database was 29. The standard deviation value of 41 is showing the variation of the different clusters we have in our database, with the maximum reaching to 15, 20, 26, the mutual number of friends. On your screens is some of the exploratory data analysis that we did throughout this project. For each of the different users, we created a unique agency matrix that was later fed onto the recommendation systems that we built. We had two different tables on here that shows the highest number of friends and the lowest number of friends in our database, the highest reaching 1095 and the lowest reaching 1. The four clusters on your screen shows, of course, the different the different number of users we were dealing with. The sparsity of the graphs being 0.04 indicates the denseness and the spreadness of the graphs. One of the interesting topics that we found out through this project was the 6 degrees of separation. If you want to reach any person on this planet, you just need to find out 6 different users that you need to connect to be friends with. For instance, if you are on the lower part of the curve and want to reach the upper part of the curve, try finding out 6 different users, and then probably you'll be able to reach the friend on top of the curve. Next, I'm going to pass on to Ashish, who's going to talk about one of the recommendation algorithms that the team used and designed.
Thank you, Saurabh. Hi, my name is Ashish. So I'm going to talk about the first algorithm. So over here, we are recommending friends on the basis of their number of mutual friends. So to evaluate our algorithm, we are using 3 approaches. The first one is Zaggard similarity. So these are the top 10 results for our algorithm run, and for our data set we found the average Zaggard similarity is 0.33. The second approach is Hamming distance. So these are the top 10 results that we have for Hamming distance, and for our data set the average of Hamming distance is 28.33. Now third approach is average index. So in this approach we randomly pick 2 friends and we disconnect them from graph, their friendship, and then we run our algorithm for both the users. So at the end, if we find one user into the other's list and vice versa, so we take the average of the indexes, else we discard it. And at the end, we put their friendship back in the graph. So from now, I will invite Kaichin to go forward with the second algorithm.
Thank you, Ashish. So I'm going to talk about recommend by inference. So there is a difference between recommend by inference and recommend by common friends. So recommend by inference is one more step towards recommend by common friends, because we also take into inference into consideration besides the common friends. So the algorithm, if you look at it, there are 3 1 here because A and B have 3 mutual friends, and then we divide it by the number of friends. So the evaluations is very similar to what Ashish has talked about. So we use the Jaccard, and then it's the similar result. And then the next one is the Hamming. We have a slightly larger number, but it's also looking good. And the next one is the average index, which is also very similar to what Ashish has talked about. And from now, I'm going to pass to Lucy.
Hello everyone, my name is Lucy. So first of all, I'm going to do a comparison between those 2 algorithms that we have just talked about. And the approach that we used is, like 3, which is generated by the index number. And you can see this plotted over here. So the blue curve is recommended by the influence, and the red curve is recommended by the number of common users. And you see like their curves are following the same pattern, up and down, and usually it will give a better result for the recommend of common users, but since it's random users, so the result can be varies with each time of the run. And the last algorithm that we have used is recommended by the similar users. For that, we first create a utility matrix, which is number of users times the number of users. And if those two users, they are friends with each other, then we put a 1 over there. Otherwise, we put a 0. And for recommend the similar users, we use the cosine distance. If those two users have more friends in common, which means they are more similar with each other, they have a higher number, which close to 1. If they are not similar with each other, it will have a number which close to 0. Then for the evaluation, we first generate a very large number, which will be used for our index. And then we iterate through this index to find for every user, would that be a utility matrix is equal to 0 or not? If it's equal to 0, we eliminate that. Otherwise, we put that into a true list. Then we will iterate through this true list to find what their recommendation would be by passing the utility matrix, user index, and how many friends that you want to recommend. And for the arrow, we will do a mean squared error, which is MSE. And here's the graph that we plot for running it for 50 times. And it's worthy to mention that for the cross-validation, we only use 20,000 users for the training process, and we use the other for the testing. And you can see here is like with the greater number of the K, the MSE is getting down, and it stays in the same level without too much fluctuation. And the result is overall pretty good in our case. And thank you guys for watching.